Hi viewers, I wholeheartedly welcome you to this particular session. In this session, we are going to explore the separation of fifth group cations. So, this is the fifth group cation solution that was supplied to me by the lab attendant. Now, I need to find out the cations present in this given solution. Now, what are fifth group cations? Generally, fifth group consists of calcium plus 2, barium plus 2 and strontium plus 2 ions. As per the latest APCHI syllabus for the first BSc students, we have all these three cations in the syllabus. Therefore, fifth group is rather important from the examination point of view. Now, how should I proceed? First, I have to add fifth group reagent to this solution given to me by the lab attendant. What is fifth group reagent? Ammonium chloride solid in excess, an ammonia solution, and then a pinch of ammonium carbonate is the fifth group reagent. So let's add the fifth group reagent to this solution to find out whether fifth group cations are present in this or not. So this is the solution that is supplied for the analysis of fifth group cations. Now to this I have to add fifth group reagent. I told you fifth group reagent is ammonium chloride solid in excess and then ammonia solution and finally a pinch of ammonium carbonate. Now let's add ammonium chloride first. I am adding ammonium chloride. I have to prepare a saturated solution. That is the reason why I am adding little excess here. Okay, so I have added ammonium chloride. Addition of ammonium chloride to the given salt solution is an endothermic reaction. As a result, if you hold or touch this particular test tube, it becomes very cool. Caution must be taken that at least little bit of ammonium chloride solid is left over at the bottom. See, I have not yet obtained saturated solution. That is the reason why I am adding some more amount of ammonium chloride solid. Okay, to this I have to add ammonia solution. So this is ammonia solution. I am adding ammonia solution. Slowly I am adding ammonia. Okay, I have added ammonia. Now I did not get any precipitate, which implies third group cations are absent. Of course, we know pretty well that it is not containing third group cations. Now I have to add a pinch of ammonium carbonate. A pinch of ammonium carbonate. I am adding a pinch of ammonium carbonate. Okay, and we'll see whether we are getting any precipitate or not. You see the beauty? We got a beautiful precipitate. So the formation of this precipitate indicates that there is fifth group cations present. Okay, what are the fifth group cations? Barium, calcium and strontium. So we have to centrifuge this. The residue will be containing fifth group cations and centrifugate is to be tested for sixth group. But right now I am discarding this centrifugate. So let's do the centrifugation now. Whenever you are keeping test tubes into the centrifuge machine, you need to keep only even number of test tubes. But because you have only one, I am taking some amount of water in another test tube, centrifuge test tube. Now I am putting them into the opposite holders as shown here. Now I am switching on the centrifuge machine. Now you observe carefully. Let us see whether the residue is obtained or not. You see a beautiful residue is obtained, which is indicating the presence of fifth group cations. So this residue contains fifth group cations and the centrifugate should be tested for sixth group. Of course, in this case I am discarding it. Now I am decanting the centrifugate from the residue. I am decanting the centrifugate from the residue. And this residue contains fifth group cations. Okay, so what should I do with this residue? To test for the fifth group cations with this residue. So to this residue, I am adding dilute acetic acid and potassium chromate. Okay, so let me add dilute acetic acid and potassium chromate. So this is dilute acetic acid. I am adding dilute acetic acid. I am adding dilute acetic acid. So I have added few drops of dilute acetic acid. Now I have to add potassium chromate. This is the potassium chromate solution I have. I am adding potassium chromate to this. Actually, you are supposed to add with the help of droppers, but I am doing it because it's a video. Okay, now I am taking little excess quantity. Okay, now this is to be centrifuged. If I get a residue, the residue in yellow color indicates the presence of barium. So let us centrifuge this. Now this is to be centrifuged. So I am placing it in opposite holders of the centrifuge machine as shown here. Switching on the machine. So you see, the yellow precipitate indicates the presence of barium plus 2 ion. So the solution that is given by the lab attendant to me contains barium plus 2 ion. Okay, yellow precipitate is indicating the presence of barium plus 2 ion. Now the centrifugate is to be tested for the presence of strontium plus 2 and calcium plus 2. I am decanting the centrifugate into a fresh test tube and I have to test for the presence of strontium plus 2 and calcium plus 2 in this centrifugate. Okay, fine. For that, I have to add ammonium sulfate to this solution. I have to heat this solution. Okay, I am adding ammonium sulfate. So this is ammonium sulfate. I am adding little amount of ammonium sulfate to this particular centrifugate. I have added ammonium sulfate. Now I have to heat this particular solution. So for heating, make use of the test tube holder. Always place your test tube at this place of the Bunsen burner for heating. So you have to do an on and off heating. Don't heat continuously such that the solution gets bumped. Okay, now I have heated. Now let us do centrifugation. Once we centrifuge this, if we get a residue, the residue indicates the presence of strontium plus 2 and centrifugate will be tested for the presence of calcium plus 2. Let us centrifuge this. I have added ammonium sulfate and heated the solution. Now I am centrifuging this. See, a white precipitate here is indicating the presence of strontium. You see here? Now this centrifugate is to be tested for the presence of calcium plus 2. This white residue indicates the presence of strontium plus 2 ion. Now I have to separate this centrifugate. This centrifugate should be tested for the presence of calcium plus 2. So I am decanting to separate the centrifugate. Okay, I have separated. Now to this centrifugate, I have to add ammonium oxalate. If I get a white precipitate, then it indicates the presence of calcium plus 2. So this is ammonium oxalate. I am adding ammonium oxalate to the centrifugate. Let me see what happens. You see a beautiful white precipitate is formed. You may be thinking that it is an yellow precipitate, but this is not an yellow precipitate, it's a white precipitate. Once you centrifuge this one, you will be knowing that it is a white precipitate. Let us go for centrifuging. So I started the centrifuging. Okay, let us remove. You see the precipitate here. What is the color of this precipitate? It is white in color. So this white color precipitate is indicating the presence of calcium plus 2. That's it. As I told you that this is containing a white precipitate of calcium oxalate. See, this is white. Actually, we were thinking that it's an yellow color precipitate, but once we centrifuge, we came to know that it is a white precipitate of calcium oxalate. So it is confirming the presence of calcium plus 2. If you are still having a doubt, we can remove this solution. We can see the color of the residue. I am removing the solution. Now you can see clear white color residue inside the test tube. Okay, a white color residue against a white background you can see. So it is confirming calcium plus 2.